Hi, this is Paul Palmer. Today I'm going to talk to you about risk management again. I know, I know I've mentioned it a few times before, but there's a lot of different aspects to risk management that some people fail to consider. And to be honest, I find a lot of people overcomplicate the issue. So, in essence, what is risk management? Well, it's looking at consumer risk versus producer risk and assigning the level of effort you're going to put into your processes and your systems and controls to either reduce your producer risk or reduce your consumer risk, and sometimes both. Now, it depends on how you look at your business, how you manage it, as to how you're going to view risk management. So, for example, in the pharmaceutical industry, we always look at the patient. But when I actually started out, that wasn't the way that I was taught about risk management. Back in 1986, 87, I was using sampling plans. And I was taught about the risk profiles and how the difference between the way that you actually select your acceptable quality level was determined by these consumer risk and producer risk graphs. Now, at the time, it was BS 6001, and it was inspection by attributes that we were using. And in the back, it had a nice detailed explanation of what we were talking about. And really, what it's about is if you've got a massive risk to the patient, then the company puts a lot of effort into eliminating that risk. If you've got a low risk, well, you need to make a decision. Are you willing to accept that risk because it doesn't cause the patient harm and maybe has a negative impact on the company if it's found? But if that is just simply a replacement and there's no detrimental impact on the patient, then is it really a problem? Maybe they've got a box of 100 and just one of the items in there is defective. And when they send you it back, you give them more than was defective to keep them happy. Are you willing to take that risk? A complaint. Then we look at deviations. Well, when things go wrong or we manufacture it wrong, we look at an AQL, we decide is it acceptable or not. Now, often people have set these limits, the AQL, the inspection level, the sampling plan, without really understanding why they're doing it. Now, the one that I was introduced to was for sterile products, and we looked at critical defects at general inspection level 2. We were using a double sampling plan and an AQL of 0.1%. But even for those products, that was just the critical. We also looked at major and minor defects. Minor defects, of course, being the ones that would have no risk to the patient. Maybe the color was slightly off, or one of the letters was slightly higher than it was supposed to be on the leaflet, but it was still on the paper, so it had no impact. Then there was the major defects. Maybe there was a potential to cause risk to the patient. And we actually had a very strong patient focus rather than a business focus. Now, if you're a manufacturing product and you had a risk to the business, say you're doing a health and safety assessment maybe, then you put your business at risk and you maybe have an explosion, well, you've got a slightly different attitude, not a slightly, completely different attitude towards risk than you do when you're actually looking at risk from the perspective of the patient. Now, you don't want to blow your business up. No, of course you don't. So you put huge effort into ensuring that that risk is completely eliminated. And you're very much on the producer side of the risk scale, eliminating that risk completely usually, because you don't want to blow people up. You don't want to destroy your own business. So you're going to do whatever you need to do and probably double and triple controls to ensure that it won't happen. But in normal day-to-day, in the routine risks that you're looking at every day, you're assessing the likelihood, the impact, and usually the detectability, although on this image we've got behind us, it says proximity. So once you've got your risk prioritization number, then you can decide whether it's low, medium, high, or and just a number, and determine what action you're going to take. Are you going to accept it? Are you going to mitigate by adding something else? Are you going to put a control in place to reduce it? Or are you going to accept the risk? Maybe it's a risk that you're willing to take, as we talked about earlier on with the complaints. But whatever it is, risk management is about assessing the situation. So you've got to identify it to be able to assess it. You evaluate your assessment and you decide what you're going to do next. It's a decision-making tool, like many others. It's not something there to write it down and say, right, I've done the risk assessment. It's, I've done the risk assessment and I've taken action. I've done this, or I've decided it's acceptable and I've signed it off and it's been approved. And you need to make sure people are aware that you've done that risk assessment. Because if something changes, then you're going to have to change your risk assessment, aren't you? If you were looking at a risk that was really low because you had 100% detection, because it actually couldn't go to the next process, then you're low risk, even if it's a critical defect. If, on the other hand, they change the machine that you're going to for a manual process, and there's no way of it stopping it going in, and then you've got a risk of it actually going out to the patient by mistake, and it's a critical defect, then you look at your risk and you think, that's not acceptable, and you can't move forward. Now, this can happen when a machine breaks down, so you need to look at your risk assessment and consider it at different times. So your machine breaks down, you're going to do it all manually, and the automatic detection is therefore turned off, and you get your defects going out that are no longer sterile. Well, that's not good enough. Absolutely not good enough. Even if something fails on the machine, maybe an automated test point fails, then that might allow critical defects to go out to the market again. And that's an unacceptable risk to both the producer and to the patient. So you want to make sure that you've got 100% detection. So probably you've got an alarm going off if it's not working, and you're going to test that alarm each day. And that's your controls you've put in place. Okay, that's it for today, talking about risk assessment. I'm going to talk to you soon.